In question 1, we have to find the coefficient of x squared in the expansion of x minus 2 upon x to the power 6. We know that for expansion, we use the formula NCR a power n minus r b to the power r. If we know the value of r that will give x squared, we can find the coefficient. So we can first find the value of r by using 6CR. Now, as we are just focusing on the variable x, so we know that a is x to the power 6 minus r and b has x to the power minus 1 to the power r, and we need x squared. So x is 6 minus r multiplied by x to the power minus r should give us x squared. We have 6 minus r is equals to 2. So 6 minus 2r is equals to 2. 2r is equals to 4 and r is equals to 2. So we can use 6c2 a to the power, which is x to the power 6 minus 2, and b to the power minus 2 upon x to the power 2. 6c2 is 15. We have 15x to the power 4 into minus 2 whole squared is 4 upon x squared. So x squared, x power 4 will become x squared. So we have 60x squared. So 60 is the coefficient of x squared in the expansion. In part B, we have to find the coefficient of x squared in the expansion of 2 plus 3x squared into x minus 2 upon x. So what we need to understand is that to get the coefficient of x squared, we'll multiply this constant term by the coefficient of x square over here and 3x squared by the constant term over here. Now we know that the coefficient of x square is 60 over here, so 60x squared. And for the constant term, which means that the power of x will be 0, we can use 6c3 as x to the power 6 minus 3 will be 3 minus 2 upon x to the power 3. So x cube and x cube will cancel and we'll have a term without x. So this will become 63, which is 10 times 63. So 6c3 becomes 20 times minus 8 will become minus 160. Now multiplying 2 by 60x squared, we have 120x squared minus 3 into 160, we have minus 480x squared. So 120 minus 480 will become minus 360x squared. So the coefficient of x squared will become in question 2, we have to express the equation 3 cos theta is equals to 8 tan theta as a quadratic equation. So we know that tan theta can be written as sin theta upon cos theta. Cross multiplying, we get 3 cos squared is equals to 8 sin. Now in place of cos squared, we can use our identity sin squared is equals to 1 minus cos squared, or cos squared is equals to 1 minus sin squared. So we have 3 into 1 minus sin squared is equals to 8 sin theta. 3 minus 3 sin squared theta is equals to 8 sin theta. Simplifying this, taking the left hand side on the right hand side, we get 3 sin squared plus 8 sin minus 3 is equals to 0. In part B, we have to find the acute angle, which means less than 90, for which 3 cos is equals to 8 tan. We know that we have simplified it in terms of sine, which is 3 sine squared plus 8 sine minus 3 is equals to 0. Factorizing this, we get 3 sine squared plus 9 sine minus 3 is equals to 0. So we have 3 sine plus 3 minus, we take 1 common, we get sine plus 3 is equals to 0. As we know, sine cannot be greater than 1. So sine theta is equals to minus 3 will be cancelled. And we have sine theta is equals to positive 1 upon 3. So taking sine inverse of 1 upon 3, we have 19.5. And as it only asks for the acute angle, so the answer would be 19.5. And question 3, we have a weather balloon, the shape of a sphere which is being inflated. The volume of the balloon is increasing at a constant rate of 600, 600 centimeter cube per second. So we know that the rate of change of volume is 600 centimeter cube per second. We have to find the radius of the balloon after 30 seconds. So the volume after 30 seconds would be 600 times 30, as it is increasing at 600 centimeter cube per second. So 600 times 30 would become 18,000 cm cube. The volume of a sphere is given by 4 upon 3 pi r cube, which will be equated to 18,000. So r would be cube root of 18,000 times 3 divided by 4 pi. So r would become 16.3 centimeters. Now it is saying find the rate of increase of the radius after 30 seconds. For rate of increase of radius, we'll first write the relation that dv by dt is equals to dv by dr into dr by dt. We have dv by dt. If we can find dv by dr, so to find dv by dr, we know that v is equals to 4 upon 3 pi r cube. So dv by dr would become 12 upon 3. So 3 multiplied by 4 will become 12. 12 upon 3 will become 4. So 4 pi r squared. And we know that the value of r is 16.3. So dv by dt is 600 is equals to 4 pi r squared into dr by dt. So the rate of increase of radius would be dr upon dt is equals to 600 upon 4 pi r squared. Substituting the value of r, which is 16.3, we get 600 upon 4 into pi into 16.3 whole squared. This will become 0.181. In question 4, the nth term of an arithmetic progression is half bracket 3n minus 15. We have to find the value of n for which the sum of the first n terms is 84. So the first step is that the nth term of any arithmetic progression is given by a plus n minus 1 times d, and that is equals to half into 3n minus 15. We can find the value of a and d through comparison. So if we expand the left hand side, we get nd minus d is equals to 3 upon 2n minus 15 upon 2. Now comparing the coefficient of n over here, on the left hand side we have d, and on the right hand side the coefficient of n is 3 upon 2. So we can deduce that d is equals to 3 upon 2. Now the term without n on the left hand side is a minus d, and on the right hand side it is minus 15 upon 2. As we have the value of d, which is 3 upon 2, we can use this to find the value of a. So a will be minus 15 plus 3 upon 2. So this is minus 15 upon 2 plus 3 upon 2. So this will become minus 6. Now we have to find the value of n for which the sum of the first n terms is 84. So we know that the formula for sum of arithmetic progression is n upon 2 bracket 2a plus n minus 1 times d. We have the sum, which is 84. N is unknown, so n upon 2 bracket 2 times minus 6 plus n minus 1 times d. And we know that d is 1.5 or 3 upon 2. So this is 1.5 times n minus 1. Cross multiplying, we get 168 is equals to n times minus 12 plus 1.5 n minus 1.5. Expanding the bracket, we get minus 12n plus 1.5n squared minus 1.5n. Simplifying this, we get 1.5n squared. Minus 12 minus 1.5 is minus 13.5n. And 165 will come on the right hand side, becomes minus 168 is equal to 0. So we can put this whole value in the calculator, or we can also make it simpler by multiplying the whole equation by 2 to bring it in integer or whole number form. So this will become 3n square minus 27n minus 336 is equals to 0. Solving this equation, we'll get n minus 16 and n plus 7. As n has to be positive, so n, the value of n will be 16. In question 5, we have a function f of x, which is a minus 2x. We have to express f of x of a and x. So for f of x, in the function f, we will replace the x by the function f, which is a minus 2x. Simplifying this, we get a minus 2a plus 4x. So this becomes 4x minus a. And f inverse of x. So for f inverse, what we do is first, in the first step, we replace the f of x by y. So we write y over here is equals to a minus 2x. Then we exchange the value of x and y. So in place of y, we get an x. And in place of x, we put a y, making y the subject. So we can bring the 2y on this side, and this will become a minus x. So y will be is equals to a minus x upon 2. So we can write f inverse of x is equals to a minus x upon 2. In the next step, we have to find the value, find x in terms of a if f of x is equals to f inverse. So we know that f of x is equals to 4x minus a, and f inverse is a minus x upon 2. Cross multiplying, we'll get 8x minus 2a is equals to a minus x. As we have to find x in terms of a, we have to make x the subject. So we can make it as 8x plus x is equals to a plus 2a, which is 3a. So this is x. So 9x is equals to 3a, and x is equals to 3a upon 9, which will become 1 upon 3a. In question 6, the equation of a curve is given where k is a constant. In part A, the line y is equals to 2x plus 3 is a tangent to the curve. So when it is tangent, it means there is only one point of intersection. And when there is one point of intersection, it means that the discriminant, which is b squared minus 4ac, will be is equals to 0. So first, equating the two equations, we get 2x squared plus kx plus k minus 1 is equals to 2x plus 3. Simplifying this, we get 2x squared plus kx. Bringing the 2x on this side will become a minus 2x plus k minus 1 minus 3 will become a minus 4. So taking x common over here, we'll get k minus 2 plus this will become k minus 4. So now we have the value of a is equals to 2, b is equals to k minus 2, and c is equals to k minus 4. Now we know that b squared minus 4ac is equals to 0, so we can write k minus 2 whole squared minus 4 into 2 into k minus 4 is equals to 0. Expanding this, we'll get k squared minus 4k plus 4. 4 times 2 is 8. 8 times k will be minus 8k. Minus 8 times minus 4 will become plus 32. Simplifying this, we get k squared minus 12k plus 4 plus 32 will become a plus 36 is equals to 0. Solving this, we will get k minus 6 and k minus 6 is equals to 0. So the value of k will be positive 6. In part B, we have the value of k is equals to 2. We have to express the equation of the curve in the form 2 into x plus a whole square plus b. So the equation of the curve was y is equals to 2x squared plus kx plus k minus 1. Replacing k with 2, we'll get 2x squared plus 2x plus 1. Now to convert it to this form, we can do that by comparison. So expanding the form that is given, which is 2 times x plus a whole squared, will become x squared plus 2ax plus a squared plus b. Simplifying this, this will become 2x squared plus 4ax plus 2a squared plus b. And we have to convert our equation, which is 2x squared plus 2x plus 1 into this form. So comparing this, the coefficient of x on the left hand side is 4a and on the right hand side it is 2. So we can say a is equals to 2 upon 4 or 1 upon 2. The constant term on the left hand side is 2a squared plus b, and on the right hand side it is 1. So in place of a, now we can substitute 1 upon 2 whole squared plus b is equals to 1. So b will be is equals to 1 minus 2 times 1 upon 4, which is 1 upon 2. So the value of b will be half. Now it is saying, and hence state the coordinates of the vertex of the curve, or basically they're asking us to tell the turning points. Now, putting the values of a and b, we get x plus half whole squared plus half. So the coordinates of the turning points will be minus half, the x coordinate will be minus half, and the y coordinate will be positive half. In question 7, we have a sector OAB with center O and radius 2r. The angle is 1 upon 6 pi radians and C is the midpoint. We have to show that the exact length of BC is r square root of 5 minus 2 root 3. So we have a triangle OCB where the two lengths and the angle between them is given, and we have to find this third length, which is CB. So we know that for this we can use the cosine rule, which is C squared is equals to A squared plus B squared minus 2AB cos theta. So in place of C, now we can write CB whole squared is equals to R squared plus 2R whole squared minus 2 times R times 2R times cos of 1 upon 6 pi. So this will become 4R squared plus R squared, which will become 5R squared minus 4R squared into cos of 1 upon 6 pi is root 3 upon 2. Cancelling this, we get 5R squared minus 2 root 3 R squared, and this is equals to CB squared. For the length of CB, we'll square root both the sides, so we can write CB is equals to square root of 5R squared minus 2 root 3R squared. Now as we have to bring it in the given form, we can take R squared common, so this will become R squared into 5 minus 2 root 3. Now we should know that if something is given in the form, let's say 4 multiplied by 10, so we can take the square root of 4, so this can be written as 2 square root of 10. Now the square root of R squared would become R, so this will become R square root of 5 minus 2 root 3. Now in the next part, we have to find the exact perimeter of the shaded region. Now the shaded region consists of the arc AB, the length AC, and the length CB. So for the arc length AB, we know that it will be S, the arc length is given by S is equals to R theta. So first we can write that the perimeter is consisting of the arc AB plus the length AC and the length BC. So perimeter is equals to R theta. So the radius is 2R times theta is 1 upon 6 pi. As we know that the arc length is given by S is equals to R times theta plus the length AC is R and the length BC is given as R times root 5 minus 2 root 3. Simplifying this, we get 1 upon 3 pi R so the perimeter would be 1 upon 3 pi R plus R square root of 5 minus 2 root 3. Now for the exact, in part C, we have to find the exact area of the shaded region. So for the area, we can find the area of the sector minus the area of the triangle. So the area of sector is given by half R squared theta, and the area of the triangle would be given by half AB sine C. So the radius is R, so the radius is 2R, so we can write 2R whole squared into 1 upon 6 pi minus the two lengths of the triangle. One of the lengths is R and the other length is 2R. So we can write half into R into 2R into sine of pi upon 6. So simplifying this, we get 4R squared upon 2 times 6. So this will become 4R squared pi upon 12 minus this 2 will cancel with this 2. So this will become R squared, and sine of pi upon 6 is half. 4 and 12 will cancel, becomes 1 upon 3 pi R squared minus 1 upon 2 R squared. Taking R squared common, we get R squared bracket pi upon 3 minus 1 upon 2. So this is the area of the shaded region. In question 8, we have a diagram which shows part of the curve y is equals to 6 upon x. The points 1 upon 6 and 3 comma 1 comma 6 and 3 comma 2 lie on the curve. The shaded region is bounded by the curve and the lines y is equals to 2 and x equals to 1. We have to find the volume generated when the shaded region is rotated about the y-axis. Now, whenever it is rotated about the y-axis, it means that we have to make sure that our equation is in terms of x. So the curve equation will be written as x equals to 6 upon y. Now, first we'll find the volume which is lying under the curve, which will give us this total volume, and then we'll subtract the volume which is lying under the line. So for volume, we use the formula pi times x squared dx. Now the limits will be 6 and 2 as the coordinates are given. So this is 6 and this is 2. So we'll write pi times 6 upon y whole squared dy, and the limits are 6 and 2. And we'll subtract it from the volume of the line, which will be 1. The equation is x equals to 1 as it is a perpendicular line at the point x equals to 1. So we'll write 1 squared dx and the upper limit and lower limit is 6 and 2. So integrating 6 upon y squared, this will become 36 y to the power minus 2. Integrating this, we'll increase the power by 1 and divided by the new power, which is minus 1. So this will become minus 36 y to the power minus 1, which can be written as minus 36 upon y. Now we'll substitute the upper and lower limits, which are 6 and 2. We can just add pi to the final answer. Minus, we know that the integral of 1 is x. So this is x and the limits are again 6 and 2. So putting 6 in place of x, we get 6, minus putting 2 in place of x, we get 6 minus 2. Substituting 6 into the equation, we get minus 36 upon 6, which is minus 6. Substituting 2 into the equation, we get minus 36 upon 2, which is minus 18, minus 4. So minus 6 plus 18 is 12. 12 minus 4 is 8. So the total volume would be 8 pi. Now in part B, we have a tangent to the curve at a point x and it is parallel to the line y plus 2x equals to 0. So the line has equation y is equals to 2x, which means that the gradient of this line is minus 2. So the tangent to the curve at point x will also have a gradient of minus 2. We know that the equation of the curve is y is equals to 6 upon x, which can be written as y is equals to 6x to the power minus 1. Finding the dy dx of this equation, we get, so we multiply the minus 1 by 6, we get minus 6. Decreasing the power by 1, we get 6x to the power minus 2, or minus 6 upon x squared. We know that the gradient is minus 2. So this will become minus 2 is equals to minus 6 upon x squared. So x squared will be equals to 3, or x will be equals to square root of 3. Now we have to show that the line, that x lies on the line y is equals to 2x. So the coordinates of the tangent to the curve, we know that the x coordinate is square root of 3. So the y coordinate at the tangent will be y is equals to 6 upon x, and the value of x is root 3. Now rationalizing the function, we multiply and divide by square root of 3 to get rid of the square root sign in the denominator. We get 6 square root of 3, and root 3 times root 3 will become 3. So we know that the coordinates of the tangent to the curve are root 3 comma 2 root 3, and these points must satisfy the equation y is equals to 2x. So we'll use y is equals to 2 times the coordinate of x is root 3. So the value of y is also 2 root 3. So basically this shows that x lies on the line y is equal. In question 9, we have two functions f and g. F of x is 2 minus 3 sine 2x, and g of x is minus 2 f of x. We have to find the range of f and g. So for the maximum value of f, we add 2 to the amplitude, which is 3, so this will become 5. And for the minimum value, we subtract 2 and the amplitude, which will become minus 1. So f of x will be greater than equals to minus 1 and less than equals to 5. As g of x is minus 2 times f of x, so for g value, we'll multiply the 5 by minus 2, which will become minus 10. And we'll multiply the minus 1 by minus 2, which will become positive 2. So this will become the minimum value and this will become the maximum value. So we can write g of x is less than equals to 2 and greater than equals to minus 10. Now in part B, we have the graph of y is equals to f of x given. We have to sketch the graph of y is equals to g of x. Now we know that this point is 2 as the graph of f of x move 2 units upwards. The highest value of g of x is 2 and the lowest value is minus 10. So let's say minus 10 is over here. The total difference between the maximum and minimum value is 12. So the amplitude would be 6, which means that the graph will start from over here. And the minus sign represents that the graph will be inverted. So the graph of g of x would be like this. Now in part C, we have a function h such that h of x is g of x plus pi. Now we know that from f of x to g of x, the function was multiplied by minus 2. The minus sign basically represents a reflection in the x direction or in the x-axis, and this 2 represents a stretch of factor 2 in the y direction. So we know from f to g, first we had a reflection in x-axis, and then we had a stretch of factor 2 in the y direction, and finally the x plus pi represents that the graph will move minus pi in the x direction. So finally we'll have a translation of minus pi in x direction. In question 10, we have the equation of a curve 54x minus 2x minus 7 whole cube. We have to find the derivative and double derivative. So for dy dx, 54x will become 54, minus 3 will multiply by the coefficient which is minus 1, 2x minus 7, and the power will become 2. And we multiply this by the derivative of 2x minus 7, which is 2. So this will become 54 minus 6 into 2x minus 7 whole squared. For the double derivative, the 54 will become a 0, 2 will multiply by minus 6, which will become minus 12 into 2x minus 7 to the power 1, and the derivative of 2x minus 7 will be 2. So this will become minus 24 into 2x minus 7. In part B, we have to find the coordinates of each of the stationary points. So for the stationary points, we know that the dy dx is equals to 0. The dy dx in part A was 54 minus 6 into 2x minus 7 whole squared is equals to 0. Taking 54 on the other side, or this equation on the other side, we'll get 2x minus 7 whole squared is equals to 54 upon 6, which is 9. Taking square root on both the sides, we'll get 2x minus 7 is equals to plus 3 and minus 3. So 2x is equals to 3 plus 7, 10. So x, one value of x is 5. And taking 2x minus 7 is equals to minus 3, we'll get 2x is equals to minus 3 plus 7, which is 4. So 4 divided by 2 will be 2. Now, putting x equals to 5 into the equation, we will get y is equals to 193. And substituting x equals to 2 into the equation, we will get y is equals to 135. For the nature of the stationary points, we'll use a double derivative, which is minus 24 into 2x minus 7. So substituting x equals to 5 into the equation, we get minus 24 into 2 times 5, 10 minus 7, which is 3. So this is a negative value, which means the coordinates 5, 193 will give us a maximum point. As when the double derivative is negative, we have a maximum point. And now substituting x equals to 2 into the equation, we will get minus 24 into 4 minus 7. This will give us a positive value. 24 times minus 3 will give us a positive value. So this will become a minimum value. So we can say that the coordinates 2, 135 will be minimum. In question 10, we have the equation of a curve 54x minus 2x minus 7 whole cube. We have to find the derivative and double derivative. So for dy dx, 54x will become 54, minus 3 will multiply by the coefficient which is minus 1, 2x minus 7, and the power will become 2. And we multiply this by the derivative of 2x minus 7, which is 2. So this will become 54 minus 6 into 2x minus 7 whole squared. For the double derivative, the 54 will become a 0, 2 will multiply by minus 6, which will become minus 12 into 2x minus 7 to the power 1, and the derivative of 2x minus 7 will be 2. So this will become minus 24 into 2x minus 7. In part B, we have to find the coordinates of each of the stationary points. So for the stationary points, we know that the dy dx is equals to 0. The dy dx in part A was 54 minus 6 into 2x minus 7 whole squared is equals to 0. Taking 54 on the other side, or this equation on the other side, we'll get 2x minus 7 whole squared is equals to 54 upon 6, which is 9. Taking square root on both the sides, we'll get 2x minus 7 is equals to plus 3 and minus 3. So 2x is equals to 3 plus 7, 10. So x, one value of x is 5. And taking 2x minus 7 is equals to minus 3, we'll get 2x is equals to minus 3 plus 7, which is 4. So 4 divided by 2 will be 2. Now, putting x equals to 5 into the equation, we will get y is equals to 193. And substituting x equals to 2 into the equation, we will get y is equals to 135. For the nature of the stationary points, we'll use a double derivative, which is minus 24 into 2x minus 7. So substituting x equals to 5 into the equation, we get minus 24 into 2 times 5, 10 minus 7, which is 3. So this is a negative value, which means the coordinates 5, 193 will give us a maximum point. As when the double derivative is negative, we have a maximum point. And now substituting x equals to 2 into the equation, we will get minus 24 into 4 minus 7. This will give us a positive value. 24 times minus 3 will give us a positive value. So this will become a minimum value. So we can say that the coordinates 2, 135 will be minimum.